All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. 10x Developer, how are you doing? Welcome. Bagat's good to see you as well. Thank you for the Hydrate Redeem. Starting off the night strong. Good to see you guys. We are going to pick up where we left off on the last stream. I just thought it would be funny to actually just kind of toss this up here since this is episode 300. I figured, why not kick it off with a bang, right? We are going to be picking up where we left off on the last episode, talking about our storage buffers, and I've got a few things that I've thought about offline. I haven't really had a chance to do much work offline, though, so we're going to talk about those things here in just a minute. But before we do, I do want to take just a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Alazaran, followed by our partners, Gaboli's Inc. and Matt Oscard. Those are the highest tiers of subscription, over on YouTube memberships and Patreon, followed by the list of supporters you see here. Scrolling by on the screen, they are a combination of the other tiers of support on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It is greatly appreciated and helps me cover the costs associated with running this channel and project. Things like software licenses, hosting fees, hardware costs on occasion, stuff like that. So it's very much appreciated. Thank you for that. Speaking of appreciation, I also appreciate each and every one of you guys, the viewers, whether you're joining us live on the YouTube side or the Twitch side. We do simulcast both, or if you're catching the VOD after the fact. Thank you guys very much for being here. I appreciate each and every one of you guys, because without you guys, this project and this channel would not exist. So thank you guys for being here. All right. Let's see. Apotham, good to see you as well. It crops the thumbnail. I assume the first G is cropped. What do you mean, crops the thumbnail? Do you mean of, like, this thing? Or are you talking about something else? If you're talking about this log down here, don't worry about that. But, all right. So, speaking of that, I wanted to kind of briefly talk about a little bit of thinking that I've been doing about how the SSBOs should be organized and how they should work. Because on the last stream, we were kind of thinking about, well, maybe we set them up in the renderer, and the renderer just kind of has these pre-existing SSBOs that exist, or I was thinking maybe even one large one. And, we just kind of use that accordingly. But the more I thought about it, the more that it started to make sense to me that maybe we should split things up a little bit differently. So I kind of wrote some notes here the other day, and I actually haven't updated this since then, but if we get thinking about it a little bit more, I think it makes more sense that we split this up into a few different categories of data, right? Because ultimately that's going to drive what is stored where and when, and how often it's updated. So material data, for example, should probably be owned by the material renderer, since that's what's going to use it. There's not really any reason for us to have any sort of ownership outside of the material renderer for the material SSBO, right? So we ought to have a dedicated one there that's owned by the material renderer, since that's really going to be the only thing that uses that data. I think that makes sense, right? Thank you for the follow, by the way. I appreciate that. Welcome. So the lighting data could thus be owned by the lighting system. So this also kind of gives us a reason to keep that. And I do need to kind of rethink how that system works a little bit, because it doesn't really do a whole lot now. And I think we could probably make some more use of that. So I'm hoping to be able to jump into that tonight as well. Obviously, the transform SSBO would be owned by the transform system. And then we could have the animation data owned by the animation system. So this is not to be confused with the skinned mesh system that we're going to write to maintain skin meshes and their states. The animation system is actually going to be a separate system that we're going to put in place purely to manage animation and animation data. So that is kind of the overall thing that I'm thinking in terms of SSBO organization. Now, one thing that we could do in the future, if we find out that there's problems with lots of overhead and having this many SSBOs, which I don't really think is going to be a problem, we could also, perhaps do some fanciness to, to basically combine this all into a single SSBO that internally manages offsets for each one of these systems. So maybe that's something we'll do in the future. But I think, at least for now, we ought to probably start with what the simplest thing is to get working. And then if we need something fancier later, we can move to that, right? So step at a time. First time chatter, like the vibe. I appreciate that. And welcome. I appreciate having you here. So thank you. Dustin, my dudes, good to see you as well. Everything is well with me. Thank you very much for asking. I really appreciate that. Yeah, things are going well here. Can't complain. Thank you for the follow. I appreciate that. I'm not 100% sure how to pronounce your name, and I'm probably going to butcher it, so I'm not even going to try. But thank you for the follow. I do appreciate that. All right. So the other advantage that we get by this is we don't have to worry about cross-cutting concerns, right? And I kind of wrote a little bit of, a little bit of a diatribe to myself here, kind of explaining it so that if I need to go back to this in 6 months going, why did I what was I thinking when I went this way? I kind of have it detailed here. But I'm thinking that it makes the most sense to do it this way because, if we need transform data in a shader, all we have to do is include that SSBO in the shader. Boom, we have transforms, right? Same thing goes with lighting data. But if we don't need it, we don't have to include it. So I think that makes it modular as well, which is also kind of a nice side effect of doing it this way. Okay, so there's that. Let's see, did I mention anything else in here? Yes. So there is one more matter, and I'm basically going to give the bottom line of this section here. There is going to be one other thing that doesn't necessarily belong in any of these groups, and that is kind of like global settings data. So things like the projection and view matrices, which, I mean, we could theoretically roll that into transforms, right? But that doesn't really make any sense when you think about it. Things like, whether or not we're using PCF on our materials in our when we're rendering our meshes, right? What render mode are we in? What's the shadow fall off? Global settings like that. There is sort of the need to have that stuff separately. So I'm thinking that is probably where we are going to go ahead and use sort of a global UBO, right? There's a few options that we could do there. We could have another SSBO, right? Another storage buffer. We could very easily create one of those, but the sort of global data that's needed for various shaders throughout the system differs slightly, right? So in some of those cases, we're going to need those shadow settings. In other cases, we're not going to need those shadow settings. In some cases, we're going to need multiple views and projection matrices. In some other cases, we might only need one. And so I think in this case, it actually makes a little bit more sense to have sort of a global UBO, similar to what we had before, already existing, but it only kind of contains those global items that we actually need, instead of kind of everything that we had before, which kind of included essentially these three, right? And so essentially the idea here is that we'll have a global UBO in addition to these storage buffers. And then we'll also have what we're going to call immediates. We've already called immediates, right? Which essentially in Vulkan terms translates to a push constant. Couldn't think of the word there for a second. We went with the term immediate because, that's something that gets immediately set before you make a draw call, and it's used right then and there. And so the underlying verbiage varies based on API that you're using. So I didn't want to call it something like push constants. And I think immediate makes more sense. So that's kind of the plan here in terms of how the storage buffers are going to be organized. Now, The other thing that I wanted to talk about tonight, and we can actually see here that I actually did start on this. We got a couple of errors over here on the Vulkan backend. Is something that I hadn't considered previously, but I got thinking about offline, which is triple buffering our storage buffers. So we're basically going to, at some point, run into a situation where we're trying to write to one of these storage buffers while it's currently being used to render another frame, right? And that obviously can have very nasty side effects, things like flickering and bouncing back and forth and jittering and all kinds of just nastiness, right? Not to mention the potential actual corruption issues that could occur there if we aren't careful. And so I got thinking about that too. And whenever we create a render buffer, we should also have the ability to triple buffer that, right? And so when we create a, let me see, where did I put that? I think I added it here. Here we go. So I added a new flag to the actual creation of the render buffer, which is triple buffered bit. Now, I do understand that we might not always be triple buffering. We might only be double buffering, right? We do support both. However, we are only going to say that we're going to support triple buffering because if we, for example, support toggling between triple buffering and double buffering, we don't want to have to create internal, extra internal resources if we switch to double buffering to triple buffering, right? We'd rather just have all the resources that we need. So even if we're only double buffering, we're going to create as if we are always triple buffering so that we have all the resources we need, even if we're not necessarily using it. Now, 9 times out of 10, the client is going to be automatically set to be triple buffering. There's probably going to be very little reason we'll ever toggle that. We might not even expose that, in the game client. I don't know yet. But since we have support for it in our renderer, we might as well think that through, right? All right. Let's see. I gotta head out and get some food and caffeine, but I'll have you on in the car. Looking forward to tonight's progress. Awesome, I appreciate that. Smudge, good to see you as well. Welcome. What's the difference between double and triple? So in general, you can essentially have a higher frame rate at triple buffering than double buffering because you are constantly making use of the GPU resources and having less downtime. So you can basically be, while one frame is being presented, you can be writing to the next frame and potentially even the frame after that. And so it reduces input lag and things like that because you're able to essentially work ahead a little bit and sort of keep the GPU being used to the best of its ability at all times. However, there are some setups that don't really support that. And so we do have double buffering as a fallback. But triple buffering is where it's at, right? We generally want to have that enabled for most of the time. Singy, good to see you over there on the YouTube side. How you doing, bud? Welcome. Happy 300. I appreciate that. Yeah. It kind of snuck up on me there. I wasn't completely prepared for it, right? I was kind of hoping that we'd be able to do something a little bit more interesting, but we're kind of in the middle of this, and I didn't really want to put that aside to kind of do something different. So we're going to keep rolling with this so that we can get animations going, right? This is a sub requirement of animations, and so that's essentially what we're working towards. So essentially what I've done here is instead of having a single internal handle on the internal buffer, the Vulkan buffer itself just now has we have VK buffer info and we have handle count, right? So the VK buffer info just contains a few properties. Essentially, the actual handle itself, the memory for that handle, and some mapped memory if the flag was set. And so for a buffer that doesn't care about triple buffering, there's just going to be one for the handle count and one in this array. Otherwise, there will be three here and here. And then essentially we link that up with the current frame when we are actually performing the renderer, right? And that's how we know which one to upload to, which one to use when we're drawing, when we go to bind, that kind of thing. So thank you for the follow. I appreciate that. Welcome. Okay. Also, I do apologize if my voice sounds a little bit nasally. The pollen levels have been out of control here lately, so my head's all full of stuff. So thank you for the 300 bits. I appreciate that. Thank you very much. Appreciate that support a lot. Really appreciate that. Thank you. Okay, so the only real difference here is that instead of creating one of those internal buffers, we just loop through and create three, essentially. Or, we create one depending on how many handles we have, right? So I just, kind of set it to go all through the same loop, so it either loops once or three times. And that's really all it is, right? That's the only difference. The only thing that I hadn't thought about is down here, and this is kind of where I left off in terms of doing the updates, is how we want to handle memory mapping, right? Because we do use this. And so typically the way that memory mapping works is it just links to a underlying call of vk map memory, which returns the block of data that it's mapped to, right? So we have that here, right? And so we map to that block of data and return that block of data, right? And so that returns a single void pointer. However, this is not going to work out of the box when we're talking about triple buffered buffers, right? I know that's a little bit weird. Triple buffered buffers. So there's a couple ways that we can handle this, and I haven't completely thought this out because this is kind of where I had to leave off in terms of off-camera work. So one thing that we could do is we could roll this data into that sort of internal buffer data structure that we have, and we could essentially just retrieve it using the internal frame at that time, which is probably the way that I'm going to go. The other option is that when we go ahead and map the memory, we don't return anything here. And maybe we do that either way. But when we go to get the mapped memory for something like this, right, we also pass in a frame number, right? So obviously that'll be, for triple buffered, it'll be 0, 1, or 2. And that seems kind of crappy to me, right? Because we've done everything possible to sort of abstract that concept from the front end. So I really don't want to go that way. And so what I'm thinking is we change our interface. We kind of do a combination, right? We change our interface. We do Vulkan buffer map memory, right? Instead of returning a void pointer, it returns nothing. And then we have render buffer get mapped memory. And instead of sort of saving off a pointer, right? We essentially say, okay, what frame are we currently on when we're getting this mapped memory, and then just return it at that index, right? It's not quite as good as just having a direct mapped index, but I don't see a better way to do it without having to expose the concept of a triple buffered buffer to the front end, which I really want to avoid, right? So that's kind of the concept there that I'm thinking. Question, why are you using tmux with WesTerm? Just because I'm used to the way that tmux works and I prefer it. I did try WesTerms and it's fine. I'm just used to tmux. Plus, also it works. It's basically the same setup that I have when I work on my Mac. And so, it's literally the same setup on both machines. So it's just consistency there as well. But yeah, I hope that makes sense. And hello, by the way. Okay, so we have. I think that is the way that I'm going to go. I think we're just going to, for now, unless we see that there's some sort of major performance benefit to doing otherwise, I think we're basically going to use this get mapped memory for any buffer that is triple buffered. We're going to basically want to call this every time we go to actually update it. I think is going to be the way that we're gonna work that. I don't love it, if I'm honest, but we're going to try it and see how it works, and we'll come up with something a little bit more robust if we need to. Okay. So, if we do map memory, we're just going to change that to void instead of void pointer, because we're not going to return that anymore. And we're going to do away with the error. And I think we can save ourselves a couple steps by moving that up there. And then, let's see, we have the internal buffer. And then, let's see, we have the index, which we have up here. So I've got sort of a thing that I've kind of written out for that. Oh wait, I don't want that here. I want that down here. I'll come back to that. So when we map the data, essentially what we're going to do is we're just going to loop through the handles and map the data directly to that structure that we have. So the internal, let's see, let me go here actually, and let's go to this. Let's see, we actually I already started this, I guess this was kind of what I had come up with. Okay, so we don't have the map to memory here anymore. It's in the VK buffer info. So that actually makes things a little bit simpler. So let's do a for u8 I equals 0, I is less than, and then we want to do internal buffer handle count, and then plus I. And essentially what we're going to do is this, right? Except instead of doing this whole return data business, we are going to do internal buffer. You know what? Let's actually take a convenience pointer to Vulkan. Was it buffer info? VK buffer info. There it is. We'll just do buff equals the address of internal buffer infos sub I. And for this guy, we'll just do a buff memory, and then the address of buff data, or mapped memory rather, right? And so we'll essentially map all three of those, right? So we've got that. Unmapped memory is essentially going to be the opposite operation. So we're just going to take this and come down here. And we'll move this down here. And we don't need the size. And I don't think this returns anything. Yeah, its return type is void. Yeah. I thought so. Yeah. Okay. So there's no VK check to run on it, right? So this just needs to be buff. Oops, I keep typing bug memory, right? So we just need to essentially unmap each one of those. In fact, I probably could just do internal buffer, infos, sub I, memory, right? Keep that simple. So that's mapping and unmapping. And then as far as get mapped memory goes, we're going to need internal buffer. So we'll need that. Let's take that. And, oh, we don't have context either. Sweet. Which means we probably also don't have RHI. We're going to need both of those. So we're going to put them here. And actually, again, I'm going to take this and move it up here, so that we always check that first. Okay, now what we're going to do is we're going to take the index. So we're going to get either the handle count. If the handle count is 1, the index is actually, that should be 0. That's a bug. There's going to be a couple places that's wrong. Okay. Glad I noticed that now. Okay, so we're going to just take the first index if the handle count is 1. Otherwise, we're going to get the current image index, which, if you recall, is just grabbing the render state from the current window, image index, right? The backend state from that. So that will give us the correct index for the buffer. And then we can actually just return the render buffers, and then handle, and then infos sub index mapped memory. And that's going to fix that issue. Vulkan buffer flush is probably going to wind up being the same thing. Let's see. So yeah, I think we can literally just do the same thing. So we can just do internal buffer, infos sub index memory dot memory. Right, that solves that issue. Let's see what other errors we have. I think it's mostly going to be fallout from that. Vulkan buffer read. Okay, so this is going to be much the same thing. This is going to be something we're going to do in the context of a frame. So that also makes sense for us to go ahead and grab the index. Let's see. So we should probably just do this up here, so we can reuse that. Let me clear that highlight. We don't really need that. So read internal. This is just going to be, let's do infos index dot memory. And I think I could just literally paste that same thing a couple more times to fix that. Let's see. Is this Wayland KDE? Yes, it is. Yep. LSR, good to see you. Welcome. I've had thoughts about like giving Hyperland another go. But yeah, for now, I'm using good old KDE. But it is Wayland, which is a heck of a lot better, at least in terms of user experience, than the X version of it, at least in my opinion. There are some minor grievances that I have with it, but infos sub index dot memory. There we go. And I suspect I'm going to need this again. Yep. So again, copy range is going to be kind of the same deal. Oh, we don't have an internal buffer, really? Oh, it's source ooh, yeah. Okay, so we're going to need to do this for the source and the destination potentially. Okay, no big deal. So we'll do source internal, and then we'll also do, and we'll just call this source index and dest index, dest internal, right? So we'll just get that for both. And then here we can just do infos sub source internal dot, of course. And then what did I do here? Infos subscript is not an integer. Oh, I typed source internal, not source index. That's why. Dingus. All right. Infos dest index dot handle. All right. See what else we got in here. All right, so this is descriptor set update and bind. And interestingly, did we already do this for... I wonder why it's bleating about this one and not this one. Let's go ahead and fix this one first. So I guess let's do... We should probably do this up here. Let's see. Do we have binding index? Image index. Okay, so I guess we can put it, I don't know, here. Oh, that's not even what I wanted to. That's actually not even what I wanted. I wanted this. Right. So, oh, we can't do this up here because we don't know which buffer we're going to be dealing with. Okay. So we're going to have to do this here. All right. And the source internal is just going to be buff in this case. And then this is going to be buff infos sub. I'm going to rename that. Let's just do, oops, if I can type correctly, index. Okay. So we've got that. And then for the storage buffer, so that's for the UBO. For the storage buffer, let's see. Context render buffers. Wow, that was just completely wrong, apparently. Cool. That's neat. That would have been a nasty bug. Okay, so what we actually need... BK descriptor buffer info. How did we set that up, actually? SSBO buffers. Did we actually even... We created the array here. It's a mid-frame array. Pbuffer info. Let me put this back for a second. So this is SSBO info. Oh, I created it, but I never filled it out. Okay, well, that's that seems fine. Let's see, SSBO info buffer. Yeah, I set the offset and the range, but not the actual buffer. What a dingus. Okay. So the buffer here is going to be, let's see, do we have the internal one? Buff infos sub index. Handle is what we want. Okay. We should be That's got to be there. Okay. I think that's correct now. I don't know how I missed that before, but I'm glad I caught it. Okay. All right, so that's fixed. Next. Let's see, command list begin. So this is the internal vertex buffer handle. So this is another thing I think we're going to have to fix at some point. Our internal vertex buffer is not triple buffered, which I think is actually causing some problems. But I'm not going to fix that for right now. But it is something we do need to eventually think about fixing. So internal vertex buffer. This is going to have to be down here, I guess. Yeah, so index. So instead of that, it's going to be infos index handle. All right. Next. It's going to be the same thing. So we can actually just do that. And then infos index handle. Okay. And oh, this is a whole bunch of barriers I set up. I guess, okay, internal index buffer. So this needs to be internal index buffer. And then this needs to be infos sub index dot handle. Whoops, dot handle. All right. And then some more barriers. So, you know what? I'm actually just going to paste this down here for a second as well, and then go back and edit this. So internal vertex buffer, and then this is going to be infos index dot handle, and then same thing right there. Whittling down the error list. Okay, so Vulkan renderer texture write data. So this is going to be the same thing. Now, this is a staging buffer. Let me see something. So this is going to be a little bit different, I think. Because depending on whether we are including it in the frame workload, or not, we might be creating one. So the frame stuff isn't actually going to apply here, but we still have to include it in the logic anyway. So we'll do infos sub-0 handle, because that is never going to be triple buffered. So that's fine. It's going to be the same thing there. And then, okay, so now we're at the point where our API change is actually prudent, right? So we should probably actually handle the creation of this a little bit differently, right? Because we have this internal shader mapped uniform buffer blocks, which is just an array of void pointers, right? And that's ultimately, like, by the time we get here, we should have already created those things, because we didn't used to actually have the flag to do that. Now we actually do. And so I'm actually going to close this buffer for a second. Right, and then close it. I closed the wrong one. Awesome. Okay, so when we actually create this, it takes in didn't we have, yeah, flags is the last parameter, right? So instead of render buffer flag none, and oh, we could actually change this to make this a little easier to use too. So this was done before we actually had the triple buffering logic in place, right? So what we were actually doing here is we were actually setting out and creating 3 uniform buffers, right? And we were just kind of handling it this way. We should probably switch this to use the new way of doing it so that it's consistent. We don't have to worry about this, and we don't have to worry about looping through this. We could just create it once. Yeah, I think that makes the most sense. So 1 per buffered image, triple buffered equals 3. We're always going to do 3. So instead of that, let's actually go to the internal shader first. And so this is going to be, instead of the uniform buffers used by this shader, this is going to be the uniform buffer, singular, used by this shader. And we're going to do, I guess we'll say, triple buffered by default. Right? And we're going to rename that also so that it throws some errors in our backend file. Okay, so mapped uniform buffer blocks is also not going to be needed because we actually already have something for that. So we don't need that either. So we don't have to zero the memory for that, and we also don't have to set up invalid buffers for that. So we can get rid of that. And now what we can actually do is I'm actually just going to take this line here and move it up here. And this is just going to be render or internal shader uniform buffer singular. And then buffer name, we're going to do this and this. But we're going to take the IDX out, right? So we'll do the kname string gets on the name, but we'll remove the index. We'll use buffer name there, and then what we'll do is we will do the flag triple buffered bit there, and that will create the internal render buffer the way that we need it to be created. And then we don't have to do this poop at all. That can all go away. Cool. So that's actually eliminated some code I didn't even think about, which is awesome. Chilling in the drive-through line, but I had a question. If you're doing a triple buffer, could you just pool a block of memory enough for 2 triple buffers and then fill and drop them as they get fed to the GPU? It would allow for double buffer fallback too. Let me reread that. So if you're doing pool a block of memory enough for 2 triple buffers, why would I want, wait. It would allow for, why would I want to do it twice though? Why would I want to do 2 triple buffers, right? I would only need 1. I mean, internally, yes, I could allocate a large block of memory and handle it that way. And maybe I'll switch to that. It's just a little bit, while we're in this phase, it's a little bit easier to have them as separate buffers so that when I'm debugging, it shows up in RenderDoc as a separate buffer. It just makes it a little easier to debug. But we could switch that in the future if that's what you're asking. Hamlet RPG, good to see you. How's it going? If I ever invented / got a hold of a time machine, I would go back in time just to have a stern talking to the person who thought of error success. Oh, I know. I know. I don't disagree. Just finished reading the parallelism and concurrent programming session from the game engine architecture book. There I learned that I knew nothing about programming. Yeah, I know. I've reread that section a few times myself, for sure. Why not status success? I think what would have made more sense, in my mind, would be error none, right? Because they are error codes. status doesn't really, because like you'd have for every other one, you'd have status error blah blah blah, status error A, status error B, status error C, and then a single instance of that would be status success, right? So I think like the error makes sense, but instead of saying error success, it should be error none. I think what makes, at least that makes more sense to me. Error success just makes it seem like it successfully errored. Yeah, I've always made that joke too over the years, for sure. It's very funny. Okay, so uniform buffer. This is destruction. So we actually don't need to do this unmap memory. All we need to do is render buffer destroy. And we can do internal shader uniform buffer and get rid of all this other crap. Actually, wait a minute. We could do this last step. I guess the last step does actually make sense. So let's take this and move it up as well, right? So that does make sense, but all this other stuff is not needed. Okay. Set binding data. Okay, so this is going to be, so this is our sort of new API that we've kind of started writing. So instead of the mapped uniform buffer blocks, and using the get current image index, right? We are going to do, I guess, it's going to be, let me think about this for a second. Render buffer, get map to memory, which should do that automatically for us, right? So that's just going to be the back end and the handle, right? Back end, handle. Do we call it handle here? What did we call it? Binding index. I guess it would be internal shader uniform buffer, be the handle there. So we could do U8 pointer block is equal to that, and we'll just cold cast this as well. Right? And then we could just do a mem copy into that, essentially. Okay, so an SSBO is going to be the same thing, pretty much. Except, actually, yeah, I think we can actually use literally the same logic here. Let's see, excuse me. We can actually just put it here. So this is just going to be buff instead. And then we don't need that. And that will do the thing for us. We don't have to think about indices or any of that kind of stuff, which is nice. Okay, so in render buffer create, we now have an error. Let's see. Mapped memory is Vulkan buffer map memory. Okay, so this might actually be a bit of a problem. Oh, I guess we can actually just literally call map memory and we don't have to worry about doing this, right? So we can actually literally just do, actually, instead of setting this, we literally just call the function. And that needs to not be done in a loop. Because it loops in and of itself. Right there. Okay. I guess, I could just move this logic, right? Maybe I should. Maybe I should just do this. Right? Maybe I should just do this. What did I do here? Did I get that right? It still doesn't seem right. Offsets, do we actually have... offset would be 0 in this case. No, we need this there. Deleted one too many. There we go. Okay. So for each one of these, we just go ahead and map that internally. I guess that's fine. Don't we actually have, though? Don't we already have the... Do we already have this somewhere? Oh, I guess we don't. We just index it everywhere. I guess that's... Yeah, it's fine. All right, I'm not going to worry about it. Okay, so next thing. Whoops. I don't know why that only had 1 plus. That's an issue. Okay, automatically remap the entire buffer range if the flag is set. Okay, so what's happened here, this is essentially going to need to do the same thing that create did. So I'm actually just going to grab this and come down here. So this is on the resize, right, which are resizing a buffer, particularly if you're making it larger, requires creating a new buffer, copying the memory over to the new buffer, all that stuff. So we are just going to essentially redo the same thing, only we're going to use, let's see, new size. I guess we'll just use new size instead of that. So that's just going to be new size. And then we can get rid of this. Okay, next one. So uniform buffers image index. Okay, so this is the update and bind, so we actually had changed this. So this is actually just going to be that now. All right, is that it for all the errors and the warnings? That is it. All right, cool. So in theory, we have triple buffered, potentially, our render buffers, whenever that flag is set. So that should be good to go. Let's see. Let me expand this a little bit so I can actually see what you guys are typing. Because for some reason, this just defaults to a really small window. Okay. Error, no error. Yeah, that's another one, right? Coffee Lava, how's it going? How's it going, man? Good to see you. How have you been? How much latency does triple buffering cause? In my experience, none. It actually reduces latency. In terms of, if you're talking input latency anyways. Might have been one of those pieces of code that will be renamed later, and later is still in the future. Yeah, no kidding. Back and no longer driving. I suppose my question made sense in my head with how I understand the current process, but which I could be way off on. I was saying having a block enough for 2 triple buffers, if this is how you are packaging up shader data to the GPU, but I agree that right now it's likely best to keep them as individual buffers. I guess my thought was more along the lines of these buffers being a queue. Oh, okay. I think I get what you're saying. So, I am planning on keeping these buffers separate just for debugging purposes. I probably will combine them in the future. But while I'm like moving all this data around, it's going to be really helpful to have those different boundaries and buffers, right? Let's see. Error success does make sense if you know what it is doing, but it definitely is one of those clear as mud situations, as my dad was fond of saying. Yeah, I use that expression all the time too. Okay, cool. So, we've done that. I'm sure that's going to cause some other issues. In fact, the front end is probably not going to like that very much. And also, we've got the lighting system stuff to figure out as well. As evidenced here by all of the light types, right? And this is in the initial scene file, which, to be honest, I'm really hard considering just deleting that. Because it's the old scene and I'm kind of tired of fixing it. You know what? I am going to do that. I'm getting rid of it. I am tired of having to go back and fix it to make it work with all these new structures when I'm just going to delete it anyways. I think that's it's about time for that to go. So that's going to be in runtime. And then source. And where did I put that? Under, was it under world? No. K resources maybe? Nope, I can't remember where I actually put it. Runtime source resources. I really need to get rid of that distinction too. Okay, so scene. Goodbye. Also, K height map terrain. Never actually used it. So we can get rid of that as well. All right, we're gonna have to do probably a clear or a clean on that and a rebuild. Because I'm sure there's some stuff that's including it that's gonna break. Okay, so bind frame. Oh, we've got that stuff to sort out too in the material renderer. Okay. I think I have most of that stuff sorted out, so we should be able to actually map that now. So I guess we can work on the K material renderer. Let's go ahead and split this up, and I'm going to go into the material standard. I guess we can use the fragment shader as our example, right? So I have actually split this up, and I did it kind of at the shader level initially, just to kind of plan out how I kind of want to do this. And so when we're talking about the structures we're going to need, the first thing I'm going to do is the light data. We're going to have this new light data structure, and that's going to encompass both directional lights and point lights. So those are being combined into a single structure. And that is so that we can jam them all into a single storage buffer for that type. Our base material data, largely unchanged. And then we have some animation skin data, which this actual shader isn't going to use, but I kind of wanted to start thinking about what that might look like. And so in our inputs, we've got this binding set 0, which we already kind of talked about, the binding sets, right? And so the global settings that I was talking about before is going to live in this UBO, right? So we've got the delta time, the game time, the render mode, the flag whether to use use PCF. And then I moved the shadow settings to be here instead of connected with the directional light, even though that's technically where they originate from. As far as the shader is concerned, that's more of a global setting. So the shadow bias, the shadow distance, fade distance, and split multiplier is all here, along with the directional light space matrices and the cascade splits. And then all of the view positions, views, and projections, those are here as well. And I went ahead and sort of detailed here how those are indexed, right? So we have in our immediates, which we'll go in here in just a second, we've got indices for these things. Um, might you have an area lights? We're going to be adding different types of lights for sure. But I'm pretty sure that most, if not all, lights can probably be represented with this data structure. I'm thinking. So we're gonna try that certainly at some point. Okay, so that's our global UBO, and then here we have sort of the different storage buffers, right? So this one is for transforms, this one is for lights, this one's for base materials, and this one is for animations. And so this is kind of what that's going to look like. Again, we may wind up actually combining these in the future, but for now, for debugging purposes, it's a lot, it makes debugging a lot easier for us to separate this stuff out. So there's that. And then of course we have, let me move this over a little bit. We have our texture and sampler bindings. That hasn't really changed, so I'm going to kind of skip over that, other than mentioning the shadow texture and sampler and the radiance textures and sampler are in binding set 0. And then we're essentially going to have another binding set that is per material, and those bindings are basically the material textures and samplers, right? So all of the material data is going to the material settings, right? All that data for base materials is going to live here. And then we'll have to obviously bind these textures, per material. So we'll still have to switch these out as we draw our materials, but we've got them organized by material anyway, so that's not really a big deal. And then we have our immediate data. And as I said, that the concept of immediates binds to, or directly translates to, our push constants, right? So this is what we're using that for. And I've kind of just put in comments here just so I can kind of keep track of our usage versus how much we have available. So here are the indices, right? So the view index, the projection index, the transform index, the base material index. We already talked about our point light indices and the number of point lights we have. So this is basically just a packed array of point light indices, right? So it's indexes or indices into this array of global lights, right? So this represents all lights in the scene. And then this represents the indices so that we have an idea of how many or what lights to actually use, right? And so we are using a UVec2 here. But we're calling this packed point light indices because we are actually packing a bunch of U8s into each element of this. So essentially, we wind up with 16 indices usable here, right? And so that is the reason that we're doing that, because we can get all of that just for the small cost of a UVec2, right? And we just unpack that using this guy here, right? So it's just a simple, bit shifting, right? Oops. Okay. Let's see. All right, so all the way back up here, we've got that. Obviously, we have an index into our cube map array as well. And then the other things that we used to have anyways, which is our clipping plane. And then we also have instead of passing like the whole structure of directional lights, that is now just going to be an index out of that light array, which is probably always going to wind up being index 0 by convention. But as far as this code knows, that's not really a thing, right? And then of course, the other thing that you'll see in here is tiling wave strength and wave speed. So these are a couple of the sort of material instance properties that we're going to have, and we're going to be adding more. So the material instance stuff, or the individual render of a material, all of that data is going to be in our immediate data as well. So right now we're actually only taking up bytes 0 through 63, so we still actually have 64 bytes worth of data available, which is, half, which is pretty good. And you'll notice we're not passing the model matrix here anymore either, right? Because that's obviously going to be part of that huge storage array. So, or storage buffer rather. So I've gone through this shader and made all of those relevant changes. So I think this is going to compile. We'll find out. I might have missed, a rename or two here and there, but I think for the most part, this is pretty good. The other thing that we should look at is the shader config, which is not a file here. It's actually in the material renderer. So we'll actually have to go to the material renderer. And you can see here I've got some left off stuff, right? Here. So a couple changes that I've made here is part of the state now includes the material global SSBO. So when I was talking about ownership and what would own those individual storage buffers, this is kind of what I was talking about. So one of them is here. One of them is in the lighting system. One of them is in the transform system. And then the fourth one for animation data is going to be in the animation system when we create that. So that's kind of the plan there. So I've got this set up. And we just have to kind of convert all of our calls to move away from the per frame, per group, per draw logic that we had before to use the new API for that. So essentially that's going to mean essentially that we're going to upload a bunch of these, right? I say upload, we actually have mapped host memory for this, right? So all we actually need to do is set the stuff. So there might not actually even be much of anything we have to do per frame there. Other than, a huge mem copy of the entire state from one side to the other. Okay, so let me see here. I believe all we did here. So we have our global SSBO here. And I think I might have already updated the shader configuration for it. Let's see, we have binding count 9, so we have our global UBO. Okay, so some of these things don't exist, right? So that's going to be, some of these names don't exist because we haven't created them, in the other systems. So I guess this one doesn't, I guess this one doesn't exist. Let's see. So we are going to have to create those. This isn't going to compile until we actually do that. So we go to Light System H. Oh, we have this here. Oops. Did I name it the same thing or did I bungle it? No, it is there. Why is that not? So we should be able to do why is that not? Oh, it doesn't like, okay, it's got issues. Okay, well, we'll come back to that. So we've got that one. The transform system, yeah, we did it here too. Okay. So systems K transform system. So that's that one. The only thing that we don't have yet is we don't have the animation system, so we have nowhere to actually place or define this one yet, which is not ideal. But essentially, what we're doing here is we are creating a shader asset, which I think I've remapped all that stuff at this point. We're creating encode because we know the size of various structures and things. It just makes kind of sense to just do it this way. So essentially what we do is we set this up, and then we serialize it to a string, and then we pass it off to the asset system to actually get loaded as a shader, right? And so it's as far as the shader system is concerned, it doesn't know that this came from code or that we generated it on the fly. It just knows that it's loading some sort of asset. Okay, so we'll have to ignore this error for now. We'll have to come back to that. Okay, so add UBO and SSBO bindings to match UBF shader. So this is the bit that I'm not sure that I want to do, because the more I've thought about this, the more that, and I think I even put a note up here, I want to unify the material shaders, right? So the fragment shaders will all be the same. The only difference will be the vertex layout, right? So the vertex layout for animated meshes is going to have the bone IDs and weights additionally per vertex, which means that those will have to have different vertex shaders, but the fragment shaders will be the same. So what I'm hoping will work is if I essentially just use the same configuration for the material standard shader and the material standard skin shader, and only swap the name of the vertex shader and its attributes, which we already have here, then I think that should just work. And then I want to eliminate the water material shader. So I want to basically take the water material shader and roll that into the material standard shader. And then just essentially change it out by material type, right? That's the plan anyway. Let me catch up on chat. Looks like there's been a few that I've missed. Sakelos Music, good to see you. How's it going? Remember a year ago when you told me not to do something? Well, I'm kind of started doing it. Okay. Do tell. Are you being a dingus? Speaking of dingus, Dingus Dev, how's it going? Thank you for the lurk. Orshi, good to see you as well. Hello, Copy Lava. That's funny. It's good to see you, Coffee Lava, by the way. Have you streamed recently? Because I don't feel like I've seen you like pop up in my notifications. It's calculated dingusing. Oh, this I need to hear. Explain calculated dingusing. You started dipping your toes in WAS API. Ooh. How do you like them apples? Yeah, that was one of those things where I was like, when you go to the doctor and, you tell the doctor, hey, doc, it hurts when I do this. And the doc just goes, don't do that. Or stop doing that. That's why I said don't do it. Because it's painful. All right. So I guess I think I can just copy pasta these bindings, to be completely honest. So let's actually just grab everything before the texture bindings. And if I put that down here, which is actually in this case going to be that, and then binding count is going to be 9, I think. Yes. Okay. So we essentially just need to do that, and I am going to combine the water shader into the standard material shader. I'd like to actually combine them all at some point, but for now, I am going to have to include a size in this too, which I don't think I have a structure for that yet, actually. I'll have to go back and fill that in. That's fine. All right, let me do this. So let's go down here to the water shader and put this in here as well. And get rid of that fix me. Okay, so now when we set up our animation global SSBO, that will just kind of fall into place and work. Let's see. It's not as bad as making a window. Depends on what you're doing with the window. Let's see. I'm hoping the rewrite of my engine isn't a dingus move. So far, I'm not sure, but the plan sounds good. I mean, do it on a separate branch, right? Pretty stuck on setting up the device and audio session callbacks. It's mostly the documentation that's creating most of the struggles. Isn't it always? Have you ever seen the X11 documentation and trying to figure that out? Or XCB? Good luck. Kind of sucks that shaders and pipelines are two separate things in the Vulkan API anyway. Yeah, I mean, they kind of, like, to them, the shader is really just the program, right? So, like, we're, I guess, kind of misusing the term shader here if we think about it. Like, but in OpenGL, for example, you don't have a concept of a pipeline, really, right? So, to me, it makes sense to, I kind of roll those things together. I combine those things together so that as far as the renderer front end knows, there is no difference between the two. A shader in this system includes, you know, the shader program itself, which is the GLSL or whatever, and the pipeline. But yeah, I agree. Sure, it's explicit, but it's like not useful. It's not explicit in a useful way, I think. And I think the more that people are starting to use dynamic state, the more they're kind of seeing that, right? Because it just, I get what they were trying to do, but it just didn't work. You can find the pipeline in the shader if they wanted to. Instead, they forced to match stuff. Yeah, and what's really annoying is if you're also using render passes, then you also have to have that link in between there, which is really weird and annoying, which is why I decided to not do that anymore. Let's see, I created a whole new Git repository since it's going to be completely different. That's not a bad idea either, to be honest. I just wish Microsoft didn't do this whole COM thing and basically forcing the use of classes / vtable. Yeah, COM is fun, isn't it? I avoid that crap like the plague. All right. I wonder how much of this is going to be set PCF enabled. Why isn't that showing up? Render buffer destroy. Oh, okay. So this just needs to be material global SSBO. And then this needs to be the render system state. So that should be state renderer. K-material renderer set PCF enabled. Now that's saying set PCF enabled. Did I get rid of that? K-material renderer update. I must have gotten rid of it. But I am getting the kvar every single time, so I suppose that's fine. So let's do this. I guess let's go to the state. And I guess that's part of the renderer state, right? Like it's... Because if other systems use it, they can kind of store it in their own state if they need to. So I think I'm fine with putting that in this state here. Right, so we'll have a B8 use PCF. And then instead of doing this, we'll do state use PCF equals that. And we just do that every frame. Now, I don't know that we necessarily need to do that every frame. We could put a to-do here and hook this up to events that fire when the value changes. I think that's acceptable. Okay, what's the next one? Okay, so here is where we're doing the apply globals, right? Which is something we have to rethink because we have this sort of old thing that followed the way that the old renderer worked with shaders, where we had this apply globals that essentially set the per frame, right? Did the bind per frame, setting uniform locations, which we don't have uniforms anymore, and doing all of this poop, right? And then we also have the bind base where we bind a specific material, and then we upload its properties to the GPU, setting flags and all that crap, and then also binding an instance and doing all that stuff. And so instead of doing these three things, what we really need to do is we need to think about how these updates should actually be applied in terms of our SSBOs, right? So, because all we really need to do here is upload our material data, which is technically kind of a combination of the globals and the bind base, right? So it's kind of, and actually I don't even think we're going to need to do the bind base other than probably setting the textures is the only other thing I can think of, right? So maybe we'll have that split out into like its own function. We'll just eliminate this guy. And then the bind instance is really just going to be a like apply immediates is how that's going to translate, right? So we're only going to have two binding sets for this. So we do have a global one, and then we do have the per base material one to set the texture bindings, and that's basically it, right? So this is actually going to wind up being quite a bit simpler in terms of what we actually send over to the GPU. Because we're not going to have to do this anymore. Essentially what we're going to have to do is get the SSBO mapped buffer, right? So that's going to be void, I guess we'll call it mapped memory. And we'll do render buffer get mapped memory, right? So that's going to be states renderer, and then states material global SSBO. That's automatically going to handle all of the frame stuff for us. So essentially, what this turns into then is, since if we take a look over here at how our shader is set up, right? We have this base material data struct, and then our buffer is just an array of those things. That's it. So when we actually set this up, we actually had gone to when we actually created this, we have the buffer size here, which is base material shader data, which is essentially this structure here, right? Times whatever the configured max material count is. Now, did we actually save that off? Because if we didn't, we're going to need to. We did not. Okay. So I guess we'll do U32 max material count, right? And we'll do, I guess we'll do this up here. Out states max material count equals max material count, right? And I'm not sure we're going to need max material instance count anymore, so I'm going to leave that. I'm going to leave that unset for a second. So essentially, what we're going to do is we are going to take this and go back down to here to where we are setting our globals, right? And we're going to take the mapped memory and we are going to say, I guess we could say data, right? And we're just going to directly cast mapped memory to that, because that is directly what is in the buffer, right? So base material shader data. And essentially what this is going to turn into is we are essentially going to take all of the data that we store in our state for all of the materials and essentially copy it to this array of base materials, right? I guess we could call it mapped materials. Sure, right? And that is actually all we're going to have to do, right? So we're going to have to take a look at all of the properties of each individual material, which I don't actually know. This is setting the UBO. Global UBO data. So we don't actually have that anymore. Do we have? K material, base material. Okay, so we can actually do... Essentially what we actually need is a way for, instead of getting material data one at a time from the material system, like we've done in the past, because we do just handle it one at a time, we actually need a way from the material system to say, give me a list of all of the material data. How do I want to do that? I almost kind of feel like we should probably expose the material system state to do that, so that we don't have to do some sort of getter like this. And then it's just a simple matter of doing one big mem copy, which will also make it available on the GPU all in one shot, and it's nice and simple. I feel like that's probably the way to do it. Well, let's see. Let me catch up with some comments here because I see there's some questions. Okay. Com is disgusting. Yeah, no kidding. I'm gonna wrap this thing and hopefully not to have to look at it in a long while. Yeah, that's why I just used OpenAL. Jeet, how's it going? Good to see you. I have one question. I got to the final round of my interview process in one of the blockchain Web3 companies. Okay. I don't feel like the product that you're developing is going to stay for long. What are your thoughts on Web3 blockchain companies? So, full disclosure, I don't know all that much about it, right? But I feel like that kind of stuff is a bit of a bubble, just kind of like AI companies are right now. And I think that bubble eventually is going to burst, right? I haven't looked into it in depth because I have that kind of feeling about it, right? It just seems kind of like a fad that's eventually going to die off. And I feel like it already kind of has a little bit, at least as far as that's concerned. But if you can get some experience out of it in the meantime, might not be a bad way to go, right? So, I mean, just weigh it out, right? Worst case scenario, if you get there and you hate it, you can always leave. That's an option too. Yeah, that's what I'm thinking about it. That moment when you write a C-like wrapper around a COM interface, which ends up being 100 times better than the COM interface, which is not a hard thing to achieve, by the way. Because COM is pretty terrible. We don't have uniforms anymore. Can you explain? Just curious. Sure. So in OpenGL, you kind of had these individual uniforms where you would at the top of the file, and this is OpenGL, or this is Vulkan style GLSL, so it's not exactly the same, right? But you'd have a whole bunch of uniforms at the top of the file individually, right? And you could reference those by name and code if you wanted to, get the uniform location, which was numeric, and then you could just reference it by that. And so, it was kind of a very convenient sort of way to actually handle data. The problem with that is you wind up updating lots of little things at once. And GPUs tend to be a little bit more, or a lot more efficient, the less round trips you have to make. And so Vulkan by default does not have the concept of uniforms. But as sort of an experiment on the channel, I was like, well, let's see if we could actually recreate that and see what that would look like, see how well it works. And I used it, I created it, made it work, used it for years, right? Literally. We created that system very early on and only are just getting rid of it in this change set, actually. And so now what we use is, uniform buffer objects, or UBOs, right? And that's essentially where you have a uniform that's a structure that contains all the data that you need that gets thrown over into the uniform all at once. So instead of having these things uploaded piecemeal, you literally create a big old block of memory that contains everything that you need, and you move it over once to the GPU instead of doing lots of little piecemeal updates. Now our system kind of had some other things in it to try and kind of prevent doing multiple copies to the GPU, but it added a lot of complexity, a lot of overhead, a lot of code. And it was one of those things that we tried. It was kind of a cool experiment. It worked well. If you want it, the code's out there. But I was like, you know what? We really ought to simplify this and just go back to using uniform buffer objects. And so when I say we don't use uniforms anymore, that's what I'm talking about. We just use uniform buffer objects instead. And so, it's just a single structure that contains all of the things that we need. Let's see, that's the goal anyways. The advantage of being anything that doesn't put you face-to-face with COM is technically better. Yes. Would have liked to write a C-style wrapper, but I was struggling too much with the macros and trying to set up the vtable, so I resigned to using classes. You can do it without classes. I was okay writing C-style C++ until I got to the callbacks. Callbacks really aren't that bad, to be completely honest. They're really not. Should be a legal requirement that all system APIs must use the C ABI. Yeah, I know, right? Yay, simple, ride waves till they crash. Yeah. Thing is, I'm on a work visa, so I need to make sure I stay at the company for long term. I think I'm going to pass. Okay, so that's a different thing, right? Yeah, I think if you're on a work visa and you need to maintain that for a long period of time, that's a lot more risky. I would agree with you on that one. Especially if you already have something. Like if you have something currently, yeah, I probably wouldn't switch if I were you. I would find something a little bit more stable to go after in that case. Cool, thanks for the explanation. All right, awesome. Glad it made sense. I thought you replaced UBOs with SSBOs. No, we use both. Nope. So a lot of our data that we are jamming into UBOs is now going to be in SSBOs. Yeah. And I was thinking, I was trying to see if I could get away without using UBOs, but it really just didn't make sense. So we're going to use both. Because there are some places it makes sense. Like for this kind of stuff, it makes sense to use a UBO because this is not enough data to warrant a storage buffer. UBOs can be faster, especially on NVIDIA hardware, you're right. Yep. AMD, it doesn't make a difference from my understanding, but on NVIDIA, they swear up and down it's faster. You mentioned COM, and I got some horrible flashbacks to days I don't want to relive. Yeah, I think anybody that's ever had to touch COM at length feels the same way. 100%. With a work visa, you have to be really careful. That company can use it against you to find something stable that you're... Wait. The company can use it against you, so find something stable that you're happy with. Yeah, exactly. That would be... Yeah. If you're on a work visa, that completely changes it, right? You got to be careful with that. Absolutely. Absolutely. Okay. So I guess this means we need a couple of changes to our material system to actually kind of do this in a little bit more of an efficient way. Because one thing I'm trying to do with all this, right, is to eliminate round trips. So we're eliminating round trips between CPU and GPU. But I also think it makes sense for us to eliminate round trips between the material renderer and the material system, right? So I think it would be nice if we could just get an array of material data from the material system. And I'm thinking we could probably literally just grab the entire state of materials, or the entire array of materials, and move it over, right? Because even if that material data is sparsely populated, we could still use handles to index into that data correctly. So I don't think that's going to be an issue. So let's look at this. So here's the K material system state, and then we have K material data materials, right? So each one of these guys has kind of what we'd expect, right? 3/4 of what we'd expect. There are some things in here like textures and whatnot, which I guess we would probably need. Let's see. Is there anything else in here though? I literally think we can actually just return that array. Like this array here. And as far as instance data goes, I think we can kind of tackle that after the fact. So I guess the only thing, we don't even have to worry about switching shaders for this, actually, now that I look at it. Because the only thing that's literally going to make a difference between the shaders is the vertex layout. And since all of this is being moved to a storage buffer, we don't even have to worry about this stuff. We will have to worry about texture binding, but that's not a big deal. We will have to bind those at one at a time, though. So we can't completely eliminate this, but we can eliminate most of what it does. All right. So if we do, we're going to have to actually take this. No, actually, we don't have to do that. We can actually just go to let me make sure that we don't actually already have a function that does this. So we have get base material data. So I'm thinking we could actually just do probably const here as well. And it's going to be a array of these. It's going to be a pointer, right? But it's going to be an actual array. So k material system get all base materials. God, I can't spell tonight. All right. Structs k material system states. So this one contains returns a constant pointer to that, right? This technically would be, well, yeah, I think that's fine. I don't think we really need to worry about const correctness here all that much, if I'm completely honest. All right. So all we're going to do here is literally just do return state materials. Boom. And then over here, we have mapped materials, and then we have k material data materials equals k material system gets all base materials, and states. Oh, do we not have that? Okay, that's not going to work. I'm surprised we didn't have that before, actually. K material system states material states, and we need to do out states material states equals engine systems gets material system, and here we just pass state material state. What is this? I think it had to be, whoops. There we go. So now what we can do is we also have the max number of shaders, right? So the max number of shaders that is, or the max number of materials rather, that is passed to this is the same max number of materials that is passed to the K material system by design. So that literally allows us to do this. So we can do U32I equals 0, I is less than state max material count plus I. And now we can actually literally just copy over all of the material properties that we need directly into this map to memory, right? So I guess we can do base material shader data. And we'll call this dest, and we'll take the address of mapped materials sub I, and then k material data, and we'll do source here, and that's going to be the address of materials sub I. I suppose I could do that just to be safe. Okay. So I think this is literally going to be mostly a copy properties. But, you know, one of these we're dealing with shader. Oops. Looks like a copy pasta from the shader itself. That should be F32. That should be F32. Okay. So we literally should be able to just copy over what we need in a loop like this. And we're literally copying to the same memory that is within the storage buffer that we need. So we can do dist, base color equals source base color, et cetera, right? I probably am not going to do all this on camera because we're just about out of time, but this is essentially what the idea is. Normal equals source normal, etc. Right? We'll do a left off here and copy all properties. Right? And the nice thing about this is all of this stuff here, like about shader usings and all this other stuff, does not, well, no, I can't say it doesn't need to happen. There is one more thing that needs to happen. We still do have to set the UBO properties for the shader. Okay, so let's do UBO globals. So we are going to have to do that. So we don't need bind frame. K shader system binding set binding data, right? So I'm just going to put this in here for future reference. We'll do shader. Binding set is going to be 0, right? So 0 for global. The instance ID do we actually have instance IDs yet? We might not actually have instance IDs set up yet. Binding index is going to be 0. Offset's going to be 0. The data and size are going to be pretty self-explanatory once we have the structure set up. I guess let me go back to really quickly. Do we have, I don't think I actually have this defined. So this is actually what we need to set up. Actually, do we need that? Do we need that publicly? I don't know that we do. Let's do, you know what? I'm actually just going to do, I'm going to do this. Let me make sure I didn't do this already here. Oh, I did do it. I do have one. K material settings UBO. Okay. So we're going to do this. Right. And with a to do. And then we can do the data is going to be the address of settings. And the size is going to be size of. K material settings UBO. All right. The only thing I don't have is the instance ID. But essentially, instead of doing all this stuff, we'll need to do the textures. Right. We do one setting of the data and then a setting for each of the textures. And that's it. So that's really going to become more apparent down here when we're setting all these individual sort of properties for each individual base material, right? Instead of having to do all that, it's just done up here. Let's see. Mahmood, good to see you. I am doing well. Thank you for asking. Appreciate that. Which GUI framework do you recommend for writing GUI tools fast? Dear I am GUI is kind of the standard one, right? That's the one most people use. If you need something quick, yeah, that's going to be the one you're going to want to go for. All right. H. Mendoza, how's it going? Good to see you as well. Unfortunately, you guys have showed up right at the end of the stream. But that's fine. We'll be back tomorrow. I am going to obviously we'll pick this up tomorrow and we'll see if we can get all of this straightened around so that we can at least have the flow of this figured out, right? And then we'll sort of work the SSBOs into the other system after that. And I'll see if I can get anything done off stream. I don't know about that though. Okay, so I'm going to pick somebody to raid. Let's see. Let me see if I can find something related first. We'll start there. And then if I can't, we'll expand our search a little bit. But while I'm looking for this, I do want to say just a quick thank you to all of you guys for being here, hanging out with me tonight, interacting, all that good stuff. I appreciate you guys, and I really do want to say thank you for you guys being here. If you haven't already, I would also greatly appreciate a follow on the Twitch side or a sub on the YouTube side, or both if you're so inclined, because I am trying to grow the channel. And I already see who we're going to raid. So we're going to raid Els Dragoon because they're a team that's making a game on the NAS using 6502 assembly. And they're building it on the actual hardware, which is awesome. So we're going to go over and see what they're up to. And yeah, thank you guys so much for being here. I will catch you guys later. See ya.